Good evening. Today I'm taking problems on limits. That is problems of limits. Okay, right? Problems of limit. Our first problem, if f colon r to r f of 2 equal to 4 and f dash 2 equal 1, then find करना है limit x tends to 2 x square f of 2 minus 4 f of x upon x minus 2. Right? Have to find the answer of these questions. I'm giving you 2 minutes. Solve this. Solve this. I'm giving you the 2 minutes. No? Okay. Now, Okay, I will solve this. This question will follow L'Hopital rules. Solve it. Verify whether this question will satisfy L'Hopital rules or not. Student, can you solve this question?
Yes, sir.
Oh, sir, topic revise that. Okay, I will do it.
Turn on your mic. Mic बंद है तेरा.
Chalo.
WhatsApp. Clear one. Sir.
Okay, I am going to revise the topic. But first of all, I will solve these questions. Okay, right? If I put x tends to 2, that is 2 in the numerator, 2 in the denominator, it will be 0 by 0. How? 2a square, that means 4. F of 2 is 4 minus 4 into again f of x means f of 2 means 4. 2 minus 2. 4 is 16 minus 16, that is 0. 0 by 0. So L'Hopital rule will follow. In L'Hopital rule, we differentiate numerator separately and denominator separately. That means we will not use UV rule, UYV rule. We'll differentiate numerator separately and denominator separately. So here limit x tends to 2, differentiation of x square is 2x. F of 2 is constant, so it will be f of 2 minus 4. Differentiation of f of x is f dash x, and denominator of differentiation will be differentiation of denominator will be, that is differentiation of x will be 1 and differentiation of 2 will be 0. So limit x tends to 2 times f of x, f of 2 minus 4 f of dash x. I'll put the limit point 2 into 2, f of 2 is 4 minus 4 into f of dash x means 2 dash f dash 2. 4 to the 8 to the 16 minus 4 f dash 2 is 1. So I will write 1 here. 16 minus 4 will be 12 answer. Okay. The answer is 12. Now I'm going to revise the limit. I think you learn limits in 11th. That's why I started problem of limits. But one group saying that please revise the topics, then start the questions. Okay, right? So I will revise the topics. That is limits. Suppose that I have LHL. LHL means left hand limit point. Suppose that I have 6.99. Anyone want to say something? Please just speak clear. Anyone want to say something? Anyone want to say something? Aman sir? Aman sir? Suppose that I have LHL left hand limit 6.99. That means it is approaching towards 7. Again, I have RHL right hand limit 6.9989. It is also reaching to 7. LHL equal? LHL equal? RHL. Right? So I'm revising the limits, okay? So LHL equal 6.99. That is approaching to 7. RHL is equal 6.9989 something. Is also reaching to 7. Here I can see LHL equal RHL. So limit exists. Okay, I can have also like that. LHL equal 6.999. It is reaching towards 7. RHL 7.0025. It is also reaching towards 7. So LHL equal RHL. Limit exists. Third things, suppose that I have LHL equal 7.0001. It is approaching towards 7. RHL 7.0025. It is approaching towards 7. So LHL equal RHL. Limit exists. Limit, suppose that x tends to 5, x square minus 25 upon x minus 5. I want to find the limit of this. So it will be, if I put exactly 5 in place of x, 5a square minus 25, 5 minus 5, 0 upon 0. 0 upon 0, it is called, it is nothing in mathematics. It is nothing in mathematics. One word substitution for it is nothing in mathematics is called indeterminate. Basically, I have 7 indeterminate form. One is 0 by 0. Second is infinity by infinity. Third is infinity minus infinity. Fourth is 0 to infinity. Fifth is 1 to the infinity. Sixth is 0 to the 0. And seventh is infinity to the 0. All are 0 by 0 form. Okay. Now, if I have infinity plus infinity, I will write infinity. If I have infinity into infinity, I will write infinity. If I have infinity plus or minus finite value, I will write infinity. Fourth, non-zero finite divided by infinity equal to 0. Fifth, 0 upon non-zero finite equal infinity. Sorry. Right? So basically, I have to find limit x tends to 5x square minus 25 upon x minus 5. If I put 5 in place of x, I will get 0 by 0 form. 0 by 0 is called, it is nothing in mathematics. One word substitution for it is nothing in mathematics is indeterminate. There are 7 indeterminate form. One is 0 by 0. Another is infinity by infinity. Then infinity minus infinity. 0 into infinity. 1 to the infinity. 0 to the 0. Infinity to the power of 0. Then infinity plus infinity. That is infinity. Infinity into infinity. Infinity. Infinity plus minus finite value. Infinity. Non-zero finite upon infinity 0. 0 upon non-zero finite. Sorry. I was right here. I was right here. Sixth, non-zero finite divided by 0 equal infinity. Okay? Right? So these are the infinity calculations. These 7 are the indeterminate form. Now I will go to the question. Limit x tends to 5. X square minus 25 upon x minus 5. X tends to 5 means I can reach 5 from right side. to 5. I can reach from left side to 5. Okay. Neighborhood of 5 to the left is 5 minus. 5 minus means 5 minus 0.000001. So that means it is 4.999 somethings. That is called 5 minus. Right neighbor of 5 is 5 plus. 5 plus means 5.00001. That means 5.0001. That is slightly greater than 5 is called 5 plus. And slightly lesser than 5 is called 5 minus. Okay. So this 5 is called limit point. Here 5 minus is called left hand limit point. Left
Huh? वाईफाई गया नहीं चल रहा चलेगा यूज करो ना सर माइक नहीं चालू है ना इसलिए
वो इधर से कनेक्ट करना पड़ेगा।
Okay.
हो गया? अरे हाँ, हो गया, हो गया।
5 minus is left hand limit point. 5 plus is right hand limit point. So I will calculate left hand limit at left hand point, limit point. So LHL is x square minus 25 upon x minus 5. Sorry, LHL means 5 minus x tends to 5 minus a square minus b square is the factor. A minus b, a plus b upon a minus b at 5 minus. That means I'm not cancelling 0 by 0. You should not write never 0 by 0 not equal to 1. It cannot be. I repeat, I told you 0 by 0 is indeterminate form. It is nothing in mathematics. So basically, I cannot cancel at exactly x equal to 5. I cannot cancel x minus 5, x minus 5 from numerator and denominator. Right? Right? Now, for less than 5, x minus 5 is very small but negative. That means suppose that I will put 5 minus. In place of x, I can put 4.99 minus 5. 4.99 plus 5. 4.99 minus 5. So this is not, these two factors are non-zero. This is not exactly 0. So I can cancel this. Therefore, 4.99 plus 5, 9.99 approximately equal to 10. That is LHL 10. Right? Now RHL, limit x tends to 5 plus x square minus 25 upon x minus 5 a square minus b square. I can write this. 25 is 5 square. So a square minus b square, a minus b, a plus b upon x minus 5. 5 plus means I can put 5.001 minus 5. 5.001 plus 5. 5.00 minus 5. So 5 point something minus 5 is non-zero, positive, very minute positive. Both are non-negative, so I can cancel. I am not cancelling 0 by 0. Okay, I am cancelling non-zero but very small. We can cancel. We can cancel non-zero quantity, right? So after adding, I will get 10.001. Approximately, I will get 10. So here LHL equal RHL equal 10. So limit exists and limit value equal 10. Limit value will be also called limit. Okay? Only limit. Right? You will say limit value or limit. Okay? So I explain you LHL, RHL, limit point, indeterminate form. There are 7 indeterminate form. Then additions, that is algebra of infinity. After algebra of infinity, I have calculated one limit value, that is limit x tends to 5, x square minus 25 upon x minus 5. That mean period, I show you how you will find LHL and RHL. So if you have x tends to a, so this x is variable, this a is limit point. Limit point will be constant, f, that is function or rule on which we will apply limit point to find limit. Suppose that this is giving the value L. So L is called limit value or limit. Right? Here A, neighborhood of A is A plus, right side, and left neighbor is A minus. A minus means A minus 0.00000000, any non-zero number after many zero, and A plus 0.000000000000. After many zero, you will write in some non-zero number, that is, I take 98. Okay? So this is called A plus, this is called A minus is left neighborhood of A. A plus is right neighborhood of A. L is the limit value. Now, if LHL equal RHL equal finite value, then limit exists. Number 2, if LHL equal RHL but equal to infinity, so LHL equal RHL, both are equal but equal to infinity, limit does not exist. Then limit does not exist. Number third, write if LHL equal finite and RHL equal infinity, limit does not exist, then limit doesn't exist. Fourth, if LHL tends to infinity and RHL finite, limit does not exist, then limit does not exist. Now the last point, if LHL equal not equal RHL and both are finite, then limit does not exist. Write this rule, all of you who are present here, right? Because these are the very important point. If LHL equal RHL equal finite, then limit exists. If LHL equal RHL both are tends to infinity, then limit does not exist. If LHL finite and RHL infinity, then limit does not exist. If LHL infinity and RHL finite, limit does not exist. If both are finite but both are not equal, then limit does not exist. So for only one case, limit will exist, and for all other case, limit will not exist. Okay? Now the one side limit. One sided limit. For one sided limit, suppose that we have f of x such that x belongs to capital A to B.
Sir, good evening. Excuse me.
Yes, good evening.
Sir, chat box check करो.
Okay.
स्क्रॉल करा कुछ कर दिया
Take the screenshot. Limit revision. Take the screenshot.
Yes, sir. If we have any doubt, we'll ask you in the chat box only.
Okay, okay.
Just check the chat box, sir.
Oh, right, right.
Thank you, sir.
हेलो कैफ सर
हाँ बोलिए अमन सर.
सर सुनिए ना, बॉयज का स्टार्टिंग का आधा घंटा छूट गया था, क्विकली थोड़ा रिवाइज दे सकते क्या आप 5-10 मिनट?
तो फिर गर्ल्स भी बोर होंगी। यहाँ तो ऑलरेडी 5-7 बच्चे मेरे जेई वाले बोर हो रहे हैं बैठ के। पूछ लीजिए गर्ल्स से, करो क्या? गर्ल्स रेडी है? मैं रिवीजन करा देता। अमन सर,
जी सर।
गर्ल्स रेडी हैं तो मैं रिवीजन करा देता।
कोई नहीं सर, करा दीजिए, 5 मिनट में झट से करा दीजिए।
ओके ओके राइट। लिमिट्स रिवीजन। I have started the lecture for limits problem because I know you learn limits in 11th classes. That's why I will started limits problem. But some student ask me to please do some revision on limits. That's why I have started limits revision. Okay. So for limits revision, I have taken different approach other than books and other for many teachers. Okay. So limits means I will not take as a literal meanings, means be in your limits. That means what's your lower point, what's your highest point. That's called literature limits. Okay. In literature limits, you learn about be in your limits. What's your lower point and what's your highest points. So you should contain in that interval. That's called be in your limit. But limits in mathematics is different. Here three different things, different point of view. Yeah.
We are okay with the chapter limits. You can start the questions.
Okay, right.
And sir, can you please keep the chat box at side?
Okay. उसको बोल.
Split, sir.
मी करून दिला असतं, वेळ नाही मला. इथं नाही, ते हे चालू आहे, ऑनलाईन आहे ते शेअर स्क्रीन. हा, स्क्रीन शेअर यांचं काही काम नाही आहे ना. त्यांचं डेट बघ पण करा ना. अरे काम तिला दोन्ही बघायचं ना. लेट्स फ्रेंड रे. साइंस बोले कैसे? यस यस सर, हो जाएगा सर।
सर्च में चला जाएगा।
बराबर, अभी लिखो। गया तो गया। सर थैंक यू।
हाँ सर.
टैग डाउनलोड करो। टैग डाउनलोड कर। वाओ।
माझ्या फोनवर करायचं.
Boys, I will take some further parts. The part you left, I will share with Aman sir. Aman sir will explain you. Okay, right? Because some students are getting bored, like girls are getting bored. Okay, right? So I will share the PDF to Aman sir. One-sided limits. In one-sided limits, I have a function y equal f of x such that x belongs a small a to a small b. A is closed, b is closed. Here I have to find limit x tends to a f of x. So I cannot find both side limit for a. Here a is closed. That means interval of a start from a close to b. So limit x tends to a f of x. Here I will find right hand limit for a, that is limit x tends to a plus f of x, and limit student one more things. Generally I write lt for limit, but you can write lim. Okay, I write lt so that I can save the time in competition. Okay, you can also use lim. Generally in board, write the lim. Okay, right? So lt, I have to find x tends to b f of x. I want to this. For b, I cannot find both side limits because at b we have to close. We cannot go beyond b. Okay, we cannot go further b. That is, we cannot take right neighborhood of b. We can only take left neighborhood of b. So if I have x tends to f of x, here I have to find x tends to b minus f of x. RHL. Sorry, here LHL, not RHL. Here I have to only find LHL. Here only I have to find RHL. Okay. These two are called one-sided limits. First is right hand side limit, and second is left hand side limit. Okay. Now, if we are sure that the limit are existing, we can directly find limit x tends to a f of x. That means if we are sure that the limit will exist, we should not find LHL and RHL separately. We will directly find limit. Suppose that I have a earlier questions, limit x tends to 5, x square minus 5 upon 25 upon x minus 5. I know limit of this question will exist. Okay, I know limit of this question will exist. So I can directly find limit of these questions a minus b, a plus b upon a minus b. Because LHL and RHL are existing, so I can cancel x minus 5. We are not cancelling 0 by 0. We are cancelling non-zero. Okay? Because x tends to 5. At x tends to 5 plus and at x tends to 5 minus. For both x minus 5 will be cancels. Okay. So now I can put 5 in place of x. So you will find 10 exactly. In fact, if you will not find 10 exact value, okay, the exact value is not 10. The exact value is 9.99 somethings or 10.00 somethings. Both are reaching towards 10. So I will say LHL equal RHL. That means limits are existing. Okay. Limits are existing. So the limits value will be 10. Now I'm saying that if the limit exists, you can directly calculate. Basically, for rational functions, limit will exist. Okay. For irrational functions, if the quantity tends to limit such that all sorts, that is all sorts are valid, you will find the limit value. Okay. But suppose that you have piecewise function. Piecewise function. For piecewise functions, you have to check the limits. That means you should not find directly limit by limit process. Okay. As you learn how to find the limits. For this process will not use in piecewise functions. For piecewise function, you have to find separately left hand limit and right hand limit. If both limits are equal and finite, then we will say limit will exist. And limit value, what is the LHL and RHL? Both are equal, that value will be limit value. Which functions are piecewise functions? I will say you. The modulus function is piecewise functions. Right? Modulus function. Number 2, greatest GIF, greatest integer functions are piecewise functions. Number 3, fractional part functions. Fractional part function. Fourth, signum function. Fifth, square root function. Okay, write these 5 names which are piecewise functions. Piecewise functions, modulus functions, greatest integer function, fractional part functions, signum functions, square root function. Okay. For these function, you have to check the limits. That means you have to separately find LHL and RHL. After finding LHL, RHL, you will compare it. Okay. Right? That's good. Now I will go further. I will take one more example of limits. Suppose that I'm starting 0 by 0 form. Now I'm starting problems on limits, okay? Now problems on limit. The first one, yeah, 0 by 0 form. That means if I will put x tends to 5, it will show 0 by 0. That means at exactly 5, it is 0 by 0. So I will find at x tends to 5 plus and x tends to 5 minus. That means I will find around the 5. If I have a limit point 5. If I have a limit point A, at A, I am find at exactly x equal to A, I am getting 0 by 0. That means indeterminate form. So I will find value around A. Around A, that means at x tends to A minus and at x tends to A plus. If the limit exists, that means to the left and to the right, both limit are equal. So I will find directly limits value by the limit finding process. Okay, right? Have you understood this, everyone? Anyone asking for? Yes, very good. Now the question is, limit x tends to 1, x minus 1 upon 2x square minus 7x plus 5. Find the limit of this question. This is the rational functions. X minus 1 is a x minus 1 is the polynomial, linear polynomial. Numerator is linear polynomial and denominator is quadratic polynomials. So polynomial divided by polynomial is a rational function. We know that limit of rational function will be always exist. There is no doubt to find existence of limit. If it is a 0 by 0 form, at exactly here limit point is 1, so at exactly x equal to 1. If I put exactly x equal to 1, so 1 minus 1, 2 minus 7 plus 7, that is 0 by 0. At exactly x equal to 1, it is 0 by 0. At exactly, yeah, solve it. One answer, one student giving the answer 1 minus 1 by 3. Is it correct? You can use two methods. The one method is by formula or by factorization method. So 1 minus 3 is the correct answer. Another student agreement with this answer. Okay. Right? So those who are giving the answer minus 1 by 3. This is the correct. Okay.
Minus 1 by 3.
Yeah. Minus 1 by 3 is the correct answer. Okay. I'm saying there is two processes to find the limit of these questions. The one process, the board method, that is called factorization method. And the another method, that is called L'Hopital method. Okay. L'Hopital. L'Hopital method. L'Hopital method only uses for two form. We have 7 indeterminate form. Okay. L'Hopital method uses only 2 form. One is 0 by 0 or another is infinity upon infinity. Okay. We cannot use L'Hopital method for other indeterminate form. Okay. But we can use by some arrangement in all form. This method, that means L'Hospital. We can use L'Hospital, L'Hopital methods in all form by some arrangements. Suppose that I have infinity by infinity, I will convert it 0 by 0. Then I will use L'Hopital method. Okay. Suppose that I have 0 into infinity into 0. I will convert this 0 upon 1 upon infinity or infinity upon 1 upon 0. Then I will use L'Hopital method. Suppose that I have 1 upon 1 to the infinity. I will take logarithm both side, or I will convert this in log form. So this will be infinity log 1 to the base e, infinity to the power 0 into e to the 0 into infinity. So I will use here 0 upon 1 upon infinity or e to the power infinity upon 1 upon 0. Then I will use L'Hopital method in power. Okay. Suppose that I have 0 to the power 0. I will convert this into log. I will take e to the power log 0 to 0 to the base e. This will be 0 log 0 to the base e. Log 0 is plus or minus infinity. Here base is more than 1, so it will be minus infinity. So I will convert this 0 upon 1 upon infinity or minus infinity 1 upon 0. Then I will use L'Hopital method in power of e. And the last form, infinity to the power 0, I will convert this into exponential with the help of log. So e to the power log infinity to the 0 to the base e. So it will be 0 into log infinity to the base e. Log into the base e is plus infinity. So I can write this 0 upon 1 upon infinity or infinity or 1 upon 0. Then I will use L'Hopital method in the power. Okay. So 1 to the infinity, we can use L'Hopital method in 1 to the infinity in power. Okay. We can use L'Hopital method for 0 to the 0 in converting e to the power, and again for infinity to the power 0. Right. So here I have started with the 0 by 0 form. Our question was x tends to 1, x minus 1. Suppose I do this question with the help of factorization first. What is the factor of 2x square minus 7 plus 5? What is the factor? Can you tell me? What is the factor of 2x square minus 7x plus 5?
X minus 1 to x minus 5.
X minus 5, 1 to x minus 5. Right? So at 1 plus I can cancel x minus 1. from numerator and denominator. At 1 minus, we can cancel x minus 1 and x plus 1 from numerator and denominator. Okay. So we left with limit x tends to 1 upon 2 to the x minus 5. Now the 0 by 0 form remove with the help of 1 plus or 1 minus. Okay. Now both are the equal, so I will put exactly 1 at the limit point. Okay. Directly. 2 into 1 minus 5. So after the calculation, we will get 1 by minus 1 by 3. Now the second method, limit x tends to 1, x minus 1 upon 2x square minus 7x plus 5. It's a 0 by 0 form, so we can use L'Hopital method. So we will differentiate numerator and denominator separately. Differentiation of x is 1. Differentiation of 1 is 0. So differentiation numerator is 1. Now differentiation denominator is 4 into x. Because differentiation of x square is 2x. 2 into 2 is 4. And differentiation of minus 7x is 7. And differentiation of 5 is 0. So differentiation of denominator is 4x minus 7. Now we'll put the limit point, that is 4 minus 7, we'll get minus 1 by 3. Good. Very good. We have done exactly right. Now I will take the second question. Limit x tends to 9 under root f of x minus 3 upon under root x minus 3. If I have f of 9 equal to 9 and f dash 9 equal to 4. I'm giving the 2 minutes. Solve it. Okay. I'm giving the 2 minutes. Okay. Solve it. Solve this question. I don't know the answer. One student saying that it's a 4. Is it correct? No, wait, sir. The one student saying 2 by 3. Is it correct? One student saying 2 by 3. Okay. Should I start the solution? Yeah, the answer is 4. One student agreement with the another student. So I think this is the correct answer. I think this is the correct answer. Why not solving? So around 9 root f of x is valid. Okay. So f of 9 is 9. So 9 is positive number and neighborhood of 9 is also positive, left or right. So root f of x is valid and root x is valid. So the limit will exist. I know it. Okay. So no need to find LHL and RLH. RHL. Now limit extends to 9. If I put f of 9, that is 3. 9 means 3. 3 minus 3 is 0. If I put in place of x 9, that is under root 9, again 3 minus 3 is 0. So it's a 0 by 0 form. So I can differentiate numerator and denominator separately. We can also solve this by formula method, but I will not do it by formula. I will do it with the help of L'Hopital law. Okay. So I will separately differentiate numerator and denominator. So differentiation of numerator is 1 upon 2 under root f of x. And again differentiation of f of x is f dash x minus differentiation of 3 is 0. Now differentiation of denominator, that is 1 upon 2 root x, and differentiation of x is 1 and differentiation of 3 is 0. So 0 by 0 form is removed now. So I can put in place of x, I can put exactly 9. Okay. In place of x, I can exactly put f of f dash 9 divided 2 under root f of 9 divided by 1 upon 2. In place of x, I will put 9. Okay. So f of f dash 9 upon 2 under root f of 9, and this will be 2 under root 9 upon 1. Okay, good. F dash 9 is 4. 2 will be cancelled out. F of 9 is 9. Root 9 is 3. Root 9 is 3. So 3 will be cancelled. We will left with 4. This is your final answer. Now do one more questions. Another problem. S tends to 0. Log 1 plus 2h minus 2 log 1 plus h upon h square. Solve this question. Log is a continuous functions. So limit of this function will be also exist. So we need not to check LHL and RHL. We will find limit by limit process. Okay. Find it. I'm giving you the 2 minute. Anyway, can do. You can solve this question by any method, whether by formula or L-hospital. Is it 0? I have to see the answer. 12th topic 1, 35. That's not correct. Okay, I'm waiting.
-1.
Yeah, correct. -1 is the correct answer, okay? 0 is not the correct answer. -1. If I put in place of H0, we will get 0 by 0 form, okay? So I can implement L'Hopital law. So with the help of L'Hopital law, I am doing the solution. The differentiation of log is 1 upon x. That means 1 upon 1 plus 2h. And differentiation of 2h is 2 minus 2 upon differentiation of 1 plus h is 1 upon h. And differentiation of h is 1. And differentiation of denominator will be 2h. Two will be cancelled out. Okay. So we will write 1 plus h minus 1 minus 2h upon. We cannot put limit at this juncture, okay? Because if you will put 0, you will put 0 by 0 again. So first of all, solve it. I will take the LCM of numerator 1 plus 2h and 1 plus h. So you will get 1 plus h minus 1 minus 2h in the numerator, and in the denominator 1 plus 2h plus into 1 plus h into h. 2h cancel out. Limit extends to 0. 1 will be cancelled out here. Minus h upon h into 1 plus 2h into 1 plus h. H will be cancelled out. Now the 0 by 0 form eliminated. So I will put 0 in place of h. So 1 plus 0 into 1 plus 0, we will get -1 answer, okay? Is it correct? These are the very good question. Now solve this question. Limit x tends to a. Let limit x tends to 0, not a. I will change the question. Limit x tends to 0. Log 1 plus x to the base 10 upon x. Find the limit of these questions. This is a very easy questions, okay? I think, but most of the student mistakes in these questions, okay? Do mistakes. So solve this question. I'm giving you 2 minutes because these are pretty good questions, but it's tricky, okay? You can solve this question within 1 minute.
Log 10.
Answer is 1, that is wrong. I don't think so.
आपण log 10 नाही आहे. आहे ना? 1 upon log.
Numerator में.
नहीं 1 upon log 10.
Numerator में क्या है? The answer is log e to the base 10. No. Log 10 to the base e. Log 10 to the base e, that means your answer. If you write in denominator, log 10 to the base e. Okay, those who give the answer 1, I know you will do it wrong. Now I'm going to give the clue. ln 1 plus x upon x, limit x tends to 0. That means limit x tends to 0, log 1 plus x. But here base will be e. ln means base e. I repeat, ln means base e upon x. If the base is e, then we will get 1. Have you understood this? Here base is 10, so we cannot implement formula directly. First of all, we have to change base of the log with the help of change of base formula, okay? First of all. So, change the base of the log with the help of change of base. Do it. Are you doing the questions or should I do? Students, are you doing the question or should I do? Yeah, good. The question is limit x tends to 0, log 1 plus x to the base 10 upon x. First of all, we will change the base. So I will write 10 to log e to the base 10 into log 1 plus x to the base e by x. Right? So it will be log e to the base 10 is constant. So I will take outside from the limit. So log e to the base 10 into limit x tends to 0. Log 1 plus x to the base e divided by x. The formula for this part is 1. So I will multiply log e to the base 10 into 1. Will we get log e to the base? Then we can also write this as log 10 to the base e. Okay? Right? Now I will take one more question. Limit x tends to 0. If nothing in the base is given, you should consider its e. Okay? If you are not finding anything in the base, you should consider e. Okay? If it is given the base, if it already given, you should consider that things. Okay? You cannot change that things. Okay? So here base is not given. So we should think base is e. Okay? Here log 5 minus x. Here base is not given. So we will think it is e. Base e. Exponential base. Okay? Whole divided x. Solve this question within 2 minutes. Solve it. We can solve this question by 2 ways. Okay? One with the help of formula and one with the help of. That's correct. One and students are giving the answer. In fact, has been already given the answer. 2 by 5. That's the perfect answer. We can implement L'Hopital law, or we can use formula. Two by 5. Here. That's a very small questions. Nothing different, nothing difficult in these questions. If you will put 0 in place of x, we will get log 5 minus log 5, that is 0 in the numerator. And you will put 0 in the denominator, that means 0 by 0. So we can use L'Hopital law. So differentiation of log x with the base e. Now one more thing I'm saying you. When you write 1 upon x as a differentiation of log x, that means base should be e. Okay? If the base is not e, you cannot write differentiation 1 upon x. Okay? So think about it. When the base is e, then you can write differentiation 1 upon x. Okay? The base is other than e. First of all, you have to convert base. That means change of base. Okay? Then we will implement differentiation. Right? So your base is already e. So differentiation of log is 1 upon x. In place of x, I have 5 plus x. And differentiation of x is 1. Here, differentiation of log 5 minus x is 1 upon 5 minus x. And differentiation of 5 minus x is minus 1, that is plus. Here you will get plus. And in the denominator, differentiation is 1. Now we'll put 0 in place of x. So it will be 1 by 5 plus 1 by 5. You will get 2 by 5. So log is continuous. So limit will be also always exist. Limit will always exist. Right? Now solve this question. Today I am doing 0 by 0. Tomorrow we will do all form. Okay? Today I am doing 0 by 0. Tomorrow we will do all the forms. Okay? Right? Solve this question. What is the solution of this question? I am giving you the 2 minutes only. First of all, you should think about this. Here root is existing. Inside root you are finding under root sine 2x. That means there is a probability that limit will exist or not exist. So you have to find both side limit. Okay? You have to find LHL and RHL. If the LHL and RHL both are equal, then we will say limit exists and the value will be what we will get, limit LHL and RHL. If the limit LHL and RHL not equal, we will say limit does not exist. This time I am giving you one of difficult questions. Okay? One of the. In this question, you have to do trigonometry. That means you have to solve the trigonometry and calculus. That means limits. If you will solve this question, that means you are close to JEE main and above to NDA. Okay? If you will solve this question, that means you are close to JEE main and very. That means your level is more than NDA.
By 4? No, 1 by 2.
Here limit will not exist. I am giving you the clue. Here, limit will not exist. No, it is the form of 0 by 0, but limit will not exist. LHL and RLHL both are different. Both are different. Okay. Sorry. Here I have 4.
इसलिए सब नहीं आ रहा था
No, find this. No, find this. Students, should I solve this question? Student? Student? Should I solve this question? Wait 2 minutes, sir. Okay. No, I'm going to solve this question. Okay. Right. So let's see this. I will take x power 4 to the left side. So x minus pi 4 tends to 0. 1 minus under root sine 2x. Okay. Right.
फिर वो कैमरा बंद कर उसका भी
No, the answer is limit does not exist. The answer is limit does not exist. Now solve these questions, okay? I will take rationalization factor of numerator of inside the root, okay? So I will multiply under root 1 plus under root sine 2x upon 1 plus under root sine 2x. This will be limit x minus power 4 tends to 0. Inside under root I have 1 minus a into 1 plus a. So 1 minus a square minus b square. So it will be 1 minus sine 2x upon pi minus 4x. Pi minus 4x. And here under root 1 plus under root sine 2x. Limit x tends to x minus pi 4 tends to 0. I will convert sine 2x into cos. Okay. So it will be cos pi by 2 minus 2x upon pi minus 4x. I can separately find limit of this part, second factor. So limit x tends to pi by 4, 1 upon under root 1 plus under root sine 2x. So limit x tends to x minus pi by 4 tends to 0 under root 1 minus cos 2 theta is 2 sine square theta. That means angle will be half. Half of pi by 2 is pi by 4. Half of 2x is x. Divided by pi minus 4x. A limit of this part will be 1 plus sine 2x means I will get pi by 2. So it will be also 1. Okay, I'm repeating it. I have limit x tends to pi by 4. X under root 1 minus under root sine 2x upon pi minus 4x. Now I'm solving it. Limit, I'm taking pi by 4 to the left side. So x minus pi by 4 tends to 0. Under root 1 minus under root sine 2x upon 4 pi minus 4x. I will take rationalization factor of numerator of the inside roots, okay? Insides of the root, okay? I'm taking rationalization factor for 1 minus under root sine 2x. So it will be under root 1 plus under root sine 2x. So I will multiply numerator and denominator both. In numerator, we can see that inside under root, we have a minus b and a plus b. In place of a, we have 1. In place of b, we have under root sine 2x. So it will be under root a square, that is 1 square, minus under root sine 2x, that means sine 2x, okay? Upon pi minus 4x. And the second factor will be in the denominator 1 upon under root 1 plus under root sine 2x. The first factor is 0 by 0. So we will calculate limit of first factor separately, and second factor is finite. So we will calculate limit of second factor separately. Okay? हम क्या करेंगे? दो फैक्टर है मेरे पास, अंडर रूट 1 माइनस साइन 2x अपॉन पाई माइनस 4x, ये 0 by 0 है. और सेकेंड फैक्टर जो है अपॉन 1 अपॉन अंडर रूट 1 प्लस साइन 2x अंडर रूट साइन 2x, ये फैक्टर जो है फाइनाइट है. तो सेकेंड फैक्टर का लिमिट अलग कैलकुलेट करेंगे, फर्स्ट फैक्टर का लिमिट अलग कैलकुलेट करेंगे. अब मुझे साइन 2x, हमारे पास कोई फॉर्मूला 1 माइनस साइन 2 थीटा के लिए नहीं, 1 माइनस कॉस साइन 1 प्लस साइन 2 थीटा के लिए नहीं है. हमारे पास जो फॉर्मूला है वो 1 माइनस कॉस 2 थीटा के लिए है, and 1 plus, we have the formula for 1 minus cos 2 theta, that is 2 sin square theta. Okay? हमारे पास 1 minus 2 sin 2 theta के लिए फॉर्मूला नहीं है, तो मैंने sin 2x को cos में चेंज किया such that हम उसको एज एज्यूम करें 1 minus cos 2 theta. ओके? तो हमने क्या किया, sin 2x को चेंज किया cos में. अब मेरे पास 1 minus cos 2 theta का फॉर्मूला है, तो हम उसको लिख सकते हैं 1 minus cos 2 theta इक्वल 2 sin square theta. जो एंगल होता है cos के अंदर, उसका हाफ होता है sin में. तो cos में जो एंगल है वो पाई बाय 2 माइनस 2x है, तो उसका हाफ एंगल जो आएगा पाई बाय 2 माइनस 2x का हाफ पार्ट जो आएगा वो पाई बाय 4 माइनस x आएगा. तो 2 sin square x sin square पाई बाय 4 माइनस x, एंड डिनोमिनेटर पाई माइनस 4x. नाउ सेकेंड फैक्टर मेरा फाइनाइट है, तो मैंने उसको अलग कैलकुलेट किया. तो अलग कैलकुलेट करने के बाद 1 का लिमिट 1 ही होता है, और नीचे अंडर रूट अगेन 1 का लिमिट 1 प्लस साइन 2x, दैट मीन्स x की जगह हम पाई बाय 4 पुट करें तो तुम्हें मिलेगा साइन पाई बाय 2. साइन पाई बाय 2 1 होता है, तो अंडर रूट 1 होगा, तो 1 प्लस 1 फाइनाइट होता है, तो तुम्हें यहाँ पे मिलेगा अंडर रूट 1 बाई 2. ओके? अब तुम्हें एक चीज यहाँ पे याद करना होगा, 9th क्लास से जो अभी कुछ दिन पहले पढ़ाया था, अंडर रूट एक्स स्क्वायर इक्वल मॉडुलस एक्स लिखना है कभी भी. एक्स स्क्वायर क्या लिखना है? मॉडुलस एक्स लिखने हैं, राइट? तो मैंने क्या किया यहाँ पे, लिमिट एक्स टेंस टू एक्स माइनस पाई बाय 4 टेंस टू रूट 2, तो आगे पॉजिटिव है, लेकिन मॉडुलस साइन स्क्वायर के लिए पाई 4 माइनस एक्स अपॉन पाई माइनस 4x. रूट टू will be cancel out. Now put h is equal to x minus pi by 4. So from here you will get 4h equal x minus pi 4x, sorry, h is equal to 4x minus pi, that means 4 minus 4h is equal to pi minus 4x. Now I will replace the pi by 4 minus x and pi minus 4x. So it will be limit h tends to 0, because x minus pi 4 tends to 0, modulus sin h upon minus 4h. In place of pi minus 4x, I will put minus 4h. Okay? You can see this. No, as I already told you that modulus is a piecewise function. So we have to find here LHL limit and RHL limit. Okay. We have to find LHL and RHL. So LHL equal minus is already minus 1 for only common factor. Limit h tends to the left of 0 dash 0 minus modulus sin h upon h minus 1 by 4 to the left of 0. Sign is negative. Okay. Graph of sign is like that. To the left of 0, sign is negative. So inside modulus, if I will eliminate modulus, I have to take minus extra sin h. Okay, good. If you understand, it's a good questions. And I think you are good students. Limit x tends to 0 minus. So minus minus is plus 1 by 4. X tends to 0 plus sin h. Sorry. Here is a minus. 1 4. This is a 1. So we'll get 1 by 4. Now RHL. H tends to 0 plus. Here you have minus 1 by 4 modulus sin h upon h. You will take minus 1 by 4 to the outside limit. Limit x tends to h plus. H tends to 0 plus. Modulus sin h upon h. Limit h tends to 0 plus. To the right of 0, sign is positive. So I will directly eliminate the modulus. So sin h upon h minus 1 by 4 into 1, that is minus 1 by 4. Here LHL not equal RHL. So the limit does not exist. Limit does not exist. That's a pretty good questions. Okay. I will take, this is the last one questions. This one will be your last questions for today. Limit x tends to 0. E to the power tan x minus e to the power x upon tan x minus x. Solve within 1 second. That's not fair. I will say solve this question within 1 minute. Okay. Solve it. Everyone. Solve this question within 1 minute. Okay. Do it in hurry. No, it's not -1. It's a +1. It's not a -1, it's a +1. Limit x tends to 0. I will take common factor outside. E to the x, so e to the power tan x minus x -1 upon tan x minus x. We have a two factor. I will solve these two factors separately. X tends to 0 e to the x into limit x tends to 0 e to the power tan x minus x minus 1 upon tan x minus x is the e to the 0 into, if I have a tan x tends to 0, we can write tan x minus x tends to 0. Okay, if I have x tends to 0, so I have tan x tends to, because tan x approximately equal to x if x tends to 0. Okay, tan x approximately equal to 0 x if x tends to 0. That means tan x minus x tends to 0 if x tends to 0, right? So the for x tends to 0, I can write tan x minus x tends to 0 e to the power tan x minus 1 upon tan x minus x. I will replace with h. Okay, so let's I take this is h. E to the 0 is 1. So limit h tends to 0. E to the h minus 1 upon h. This is the formula. The formula of this is 1. Okay, so 1 into 1 is 1. So have you understood this question? Write the formula. X tends to 0 e to the x minus 1 upon x is 1. Everyone, have you understood this question? Okay, so this was the last question for today. That's enough for today. Okay, we will leave. Okay, thank you. Join the tomorrow lecture. Bye.